Hello, this is Hallicrafters Rehabs. Welcome back. So now it's time to put in a digital frequency display on the SX-71 shortwave receiver. Up to now I've been putting in a buffer board in my restored receivers using my own printed circuit board based on the buffer circuit featured in Mr. Carlson's Lab YouTube channel. Once a buffer is installed, this is a through-hole type, you can drive a programmable frequency counter. I've been making through-hole printed circuit boards up to now using the toner transfer method, but for the SX-71, I decided to try a surface-mounted board. I used the toner transfer method, and my first few attempts were no good. The printer was not set to fine, and the result was a grainy copper surface. It's hard to see that here, but then the paper was not run enough times through the laminator, and the edge of the toner peeled off. So once I ran the printer on the fine setting and the paper and board through the laminator 15 times, I got a good board. The advantage of a surface-mounted board is a much smaller size for the printed circuit board and a smaller footprint inside the radio. Perhaps it's a bit more stable as well. I'm using a simple tube shield soldered to a shielded cable as a pickup for the buffer. The shield has been cut off at the bottom to prevent grounding out the shield. The 6C4 oscillator tube is then fitted with the shield to pick up the oscillator signal and frequency. So I populated the board, and it's a bit of a mess. It's my first surface-mounted circuit board. First I selected the wrong part and had to switch it out, and then there was a lot of trouble keeping the component in place. They're so small. And I pulled off a trace while I was soldering and had to repair that. But horrible as it looks, as a first try, well, maybe it will work. So I have temporarily hooked in the buffer board into the radio set with a drawing power from the little DC power supply for the circuit board and for the Bluetooth, and which is right there, and then brought the signal in, and then we'll look at it down here on the scope and see what kind of signal we're going to have. So now we're looking at the output of the buffer board and connected to the pickup, which is the shielded cable from the oscillator tube. And we see there's a good signal there. And so we're pretty happy with that. You can see as we change the frequency up and down, you can see that the oscillations change in frequency. So it's working as intended. So I'm also switching around from one band to another and moving up and down the dial. You can't really see that part. And then you'll see that the response also changes from one, along the frequency. There may be some instability that we're seeing here where the signal's not strong enough. Now we're looking at band 5. And again, there is a sufficient signal from this buffer board, which is really not intended to operate as high in frequency as we are now, but it seems to be doing okay. When you can see the digital frequency readout on the counter, when you turn, but it's not completely stable all the way through. Sometimes it'll just it'll cease to the right, like right there. It just ceases to provide a count. So, but still, that's pretty amazing. So, as we move back down the bands and different frequencies, we see there are places where there's just instability coming out of this first attempt at a surface mount printed circuit board. I think we're just going to have to give it another shot and try it again. It's just not going to be good enough. Well, funny thing, I decided to directly connect the frequency counter to the pickup, and lo and behold, there it is. No buffer board required. I should have known that. I'm in the habit of making buffer boards because the SX-79s that I restored did not have a separate oscillator tube, so there was no opportunity to use the tube shield as a pickup. On the SX-99s, the mixer is also a metal tube, so it just can't be done that way. You have to pick up the signal by directly connecting to the cathode. So look how stable it is, though. And what a pleasant surprise. But the issue with the SX-71 is that there will be two frequency counters required. One will be programmed for 455 kilohertz IF on bands 1 and 2. And then you'll switch to the other one at 2.075 megahertz, it's programmed for bands 3, 4, and 5. And I'll have a double pole, double throw switch to switch between the two. But still, this is really good progress. One thing I discovered, though, when I connected this up and programmed the frequency counter, is that the alignment of the oscillator to the dial for both bands 3 and 4 were way off. 3 megahertz too high on band 3 and 3 megahertz too low, or something like that. Basically, it was on a harmonic, the wrong harmonic of the oscillator that the alignment was to. And to explain that, we have to go to the whiteboard. So what we're looking at here is the formula every radio designer has to use to determine how to set up the radio to give a frequency readout according to whatever dial you're using, and frequency equals 1 over 2 pi to the square root of the inductance times the capacitance rules under all circumstances. Now, this area here is the inductance, the coils. It's actually a transformer with a primary and a secondary. And then that's multiplied by the capacitance here to get a resonance. Resonance is the right word, not a residence. And so then the square root of that, and the 2 pi and so forth, gives you the frequency. But it's not just that capacitance. It's also this capacitor, which is called an oscillator trim in the service manual. It's kind of like a biasing capacitor because it will place the whole resonance of the band at the right point in the frequency response of the radio, and you switch from one to another. And then you have the main tuning condenser. That's a little herringbone like capacitor in the middle of the radio with the main tuning band, and it's the one associated with the oscillator, and then there's one for the band spread. And what you do is you add the capacitance of the band spread, the main tuning capacitor, the trim, and then the resonant capacitor to get the total capacitance for determining the frequency of the radio along the band. Now, the main tuning capacitor tends to be a 50 to 450 in that range in picofarads and 5 to 50 picofarads in the band spread. Now, if you're doing a radio, say from 550 to 1700 kilohertz, that's a pretty wide area. It's like a ratio of like 3 to 1. So there's a separate formula for designing really what this oscillator trim or capacitor is going to be, so that your dial will track all the way through, basically at 3 times the frequency. So you only get one main tuning condenser, and you switch it from one band to another, and then you have only one band spread, and it's also switched at the same time from one band to another. So that will vary between 50 and 150, and it'll go from 550 on the dial to 1700. And then you'll have a general inductance there from the coil, and then that capacitance. So you'll almost always have to have some kind of capacitor right there called the oscillator trim. So to give you an idea on how they compose a radio dial, I've got 3 curves here. One, in the blue one in the middle, is an inverse square root function. The red one is an exponential function, and the gray one is a logarithmic function. Frequency follows an inverse square root function. And that's what you see, how the numbers are laid out on the dial according to an inverse square root function. The exponential is too steep, and you wouldn't be able to read the high numbers on an exponential function. And the logarithm, it's not a logarithmic function, even though people kind of call it that. So we can thank God that he figured out how to make radio dials easy to read with an inverse square root function. So in order to make band 4 orient in the middle of the band and track properly, I had to, there is a capacitor buried under here, which is a 220 picofarad capacity, and I had to replace that. There it is in the diagram I showed you. I had to replace the 2200 picofarad capacitor with 2 390 picofarad capacitors in parallel, which gives me a sum total of 780 picofarads. Quite a difference. Here in band 3, I had to add a 33 picofarad capacitor in series with the capacitance that's already there in order to make it track properly. And it's actually in series with that trim capacitor. I also found with the frequency counter that band 5 was way off. And so I had to, there is no oscillator trim capacitor. And also, another problem occurred earlier when I was working on all this. I dropped this little silver microcapacitor, which adjusts the frequency of band 5 on the floor, and cracked it. And then I super glued it back together and forgot about it. Then in this last round, I was working with, you have to remove them all to get those capacitors in there, and it fell apart in my hand. So I happened to be at Hamfest, and there at the Hamfest there was a box of all these silver mica capacitors, and for only $5. So I picked this one up, which is mil spec, and it's not plastic. It's ceramic. That's a little probably more delicate, but anyway, I put that in, and I did have to insert also for an oscillator trim of high precision 200 picofarad capacitor as an oscillator trim for band 5. So everything's back together and it's working. All the bands are tracking the way they are, and what the signal generator says is what the frequency counter says, which is what the radio dial says, and so we're basically done here. So now I could only find this one Hammond box. I didn't want a high profile, I wanted a low profile for the two frequency counters because I just don't have enough room to have tall boxes. And so there's two frequency counters in there. I cut out the place for the dial to read out, put a piece of plastic over it, painted the back side, and so forth. And they're mounted inside the box, and you can switch between the two using this double pole, double throw switch. And there I am switching from one to the other frequency counter, and neither one are programmed yet. And then the signal and the DC power for these frequency counters goes back through a shielded 2-conductor cable back to the radio, which is wired to the pickup and to the DC power supply. The big moment has come, and now it's time to put everything into the case. This case has not seen the radio inside of it since probably April or May or something like that. It's been a long time. It's probably been over 6 or 7 months that I've been working on this thing and doing all the testing that I do. And manipulating this big behemoth is difficult. I have to lift up this by the transformer to get it inside. This is the best way to do it. And then you just have to manipulate this chassis a little bit at a time into the case. It's a bit challenging when you have a plate and 12 screws in your right arm. And this thing is so incredibly heavy. So we just sort of nudge this back in there a little bit at a time. You'll get to the back here. Yeah, we're just walking it up here. And this is a time to put the cables through, yeah, before we get them pinched. Nothing goes fast this way. Now there'll be some catches there, so you just have to lift it up over those catches to finish up getting the case inside. Or I should say the chassis inside. Okay, it's almost there. It literally will snap, or almost snap, into place. There we go. Now, the first thing you want to do is you want to put the screws in the sides. So I'm going to spare you with all of that kind of stuff. But you put the screws in the side, then you put the lid on and screw it in, and then you turn it upside down and put the screws in the bottom. Well, completion, it's all done on this SX-71 and ready to be placed in its place of honor on the listening shack here. In the lower left hand corner is where it will go. These are the other radios there. Have a bit of a noise problem in here with internet and all kinds of cables, noisy cables and printers and everything. It's a RF mess right now. So we're going to have to do some reconfiguration there. What you're looking at there is a restored SX-99, and that's the other SX-99 I restored. And then I have a 100 that will eventually be restored there. So that's the end of this video. The next one will be looking at the shack.